Hello everyone, and this is going to be a series of videos on using MaterialX in Karma XPU. So first of all, what exactly is MaterialX and what is Karma XPU? So in Houdini 18, Side Effects introduced a new context called LOPS or Solaris, one and the same thing. LOPS stands for lighting operators. Okay, so essentially LOPS is an area where you can do your full scene layout, do lighting and materials, and also you can export the entire scene as USD for easier sort of data transfer between multiple softwares or any software that supports USD. So USD is the new scene export format that was developed by Pixar. It's an open source scene exchange format, and Solaris is completely built around USD. So any renderer that has to work in Solaris or in LOPS has to, understand or has to be able to read USD. Okay, so in order, when they built Solaris, they also built a brand new render engine called Karma. In Houdini 18, Karma was completely CPU based. With Houdini 19, they introduced an alpha version of a new renderer called Karma XPU. Okay, so Karma XPU uses your graphics card and your processor both. The thing to remember is it is an alpha level product, which essentially means that not only does it have stability issues, but it also has major features missing. Okay, so it is still in feature development. So hopefully my guess would be by Houdini 20 it should be more mature. With Houdini 19.5, I'm pretty sure they will introduce much more, a lot more features to it. Okay, so that's Karma XPU. What is MaterialX? So MaterialX was developed by Pixar along with USD, so that when you export your USD scene for the other software to be able to read the materials, they built a sort of singular material format called MaterialX. So if you are using MaterialX in Houdini and then you apply those materials and you export your scene as USD, and if let's say you take it into Maya and then Maya also is able to understand MaterialX, so the materials will remain the same, like you won't have to rebuild the materials. Okay, so that is primarily what MaterialX is. So with Karma XPU, it's built completely around USD and it only uses MaterialX. It does not use the old Vex based shader system. So which is why I'm covering MaterialX, because even if it's not now, but eventually with like 19.5 or 20, you will, if you want to start using Karma, you will need to know MaterialX. Okay, now it's not complicated or difficult, but it, might as well cover it. Okay, so the big reason or the big question is, why do you want to use Karma XPU? I don't use Karma CPU. I find it too slow. Okay, so why would you want to use Karma XPU? Well, single reason, it is ridiculously fast. Okay, so this is the grassland scene that I had made, which I did the tutorials for. This is my full scene, and this is currently 1280 by 720. Okay, but if you just want to see configuration time, my PC is pretty high end. Okay, so it's a 3080 Ti and a 2080 Ti and a 16 core Threadripper. Okay, but keeping that aside, it is still a pretty fast render engine. Okay, so if you sort of move around, you can sort of see how quickly the whole thing sort of resolves. This is only 128 samples. It's not a lot. Okay, but it resolves almost like, this is a 1 second render. Okay, which is kind of shocking, right? Like if I zoom in a bit, let me try to adjust the focal length. So yeah, so the primary reason of why you would want to use Karma XPU is simply because it is really, really fast. Okay, so you would want to, eventually. So one of the big reasons is, if you don't have Octane or Redshift and you want a full GPU based render engine, Karma XPU would be a really good alternative in the near future. Okay, like as I said, with 19.5 or 20, it should become a pretty good alternative. And it is really fast, which is, honestly, that is the only reason why I'm even making a video on MaterialX, because if Karma XPU wasn't fast, I wouldn't even think of doing it. I'm pretty happy using Octane. and I'm sure a lot of people are happy using Redshift or whatever. But Karma XPU is genuinely fast, so it kind of makes sense. Like, why not have another render engine, in your arsenal? So to get started, the first thing, as I said, is Karma XPU does have a lot of features missing, and also MaterialX has a lot of features missing, because even MaterialX is a fairly new material system, but I'm guessing the code is completely open, so side effects should be able to build whatever tools that it wants. Okay, they've already built a fair bunch of nodes and tools in there, but I'm sure, like, as time passes, they will build more, but right now it is pretty limited. Okay, so the things that I know are missing is, the big one for me is there is no subsurface scattering. Like Karma XPU does not. MaterialX supports subsurface scattering, and you'll see it in Karma CPU, but Karma XPU does not have support for subsurface scattering. So that's one of the big things that's missing. When it comes to procedural textures, there is very little. Okay, like Mantra has a ton of patterns and textures that come in, but like, you have your bricks map and checker map and hex style, all of that stuff. MaterialX has nothing. It has 4 noise maps, fairly rudimentary. Beyond that, it doesn't have anything. It does have a fair bunch of math tools, math nodes, so you can use those, so that's nice. The material system is pretty decent. It's the material system, or the standard material, reminds me a bit of the Arnold standard shader, so that is kind of nice. But yeah, there are limitations. Okay, so to get started in this lesson, I'll keep it fairly simple. We'll just go through the basic material and see what all features are there, and then we'll build a simple material in like Substance Painter, and then recreate that in MaterialX. Okay, so that's what we'll do in this video. So I'll open up a new file. Let me turn this off. Okay, so to get started, I'll just create a LOP network, and I'll create a SOP create. Now I'm not going to get into the USD stuff and everything. We'll make a scene, or we'll make an object, assign materials, add a light, and hit render. Like, that's what we're going to do. Okay, so let's call this toy. Okay, and I'll also just turn on the I'll split pane top bottom, and we'll bring up the Solaris scene graph, because this is how, like, when you're assigning materials and stuff, this is how you'll end up going about doing it. Okay, I'll create a material library. Okay, first of all, let me make something. So I'll just create a test rubber toy, because I have built a Substance Painter material, and we'll use that. That's been built using the test rubber toy, so that's why I'm making this. Okay, so I'll just turn off the shader. I don't want anything, and we'll plug this in. I'll come into the material library and type in standard, and you'll get the MaterialX standard surface. There's a full tab here for MaterialX, so you'll be able to see like all the stuff that is available for MaterialX. And what you want is like the standard material. Okay, so if you come to PBR, you'll be able to find there's also like a USD preview surface. Don't take that. We want the material standard. Okay, screw that. I'll just type in. Yeah, you might hear some construction work going on in the background. Like, there's major construction work going on everywhere around here. Okay, so let's just call this something. We'll call it basic. And you can do a drag drop and assign it. So I can just drag it and assign that, and set material on mesh 0. So where's mesh 0? This is it. Like the object is called toy, and inside that you have the mesh called mesh 0. What it will do is it will create this assign material node, and just, this is the primitive, and that's the material path. Okay. Okay. And then we'll take a dome light. And what I want to do is I just want to pick up like an HDR. So I'm going to take, like, I have a studio HDR. Okay, so we'll just pick that up and pick up Karma. Okay, that's pretty much it. This is the scene that we want. And change the rendering engine from CPU to XPU. Okay, so just to show you the speed difference, since that's what we're doing, I'll just turn off the grid. Now, okay, let me just bypass this temporarily, like the material assignment. Okay, now if I switch this to Karma, so this is the CPU version. Okay, and it's not bad. Like if I zoom in close enough, you'll see like it's pretty grainy, like it takes a fair bit of time to clean up. Now let's switch this over to Karma XPU. Okay, and if I hit Karma, there you go. Okay, like it's actually that fast. Now the default samples are extremely low. It's at 9, so we'll make it around 64. But there you go. Like the difference between CPU and XPU is sort of like night and day. Okay, it is genuinely fast. Okay, now when you assign the materials, XPU takes a little bit of time to sort of kick off again because it has to compile the material. So that sort of slows things down a bit. But yeah, sometimes if you find, like after assigning the material, if you find a bit of a lag, give it a few seconds, it will catch up again. Okay, so this is the basic material that we have. Let me just jump in and we'll just go through the material parameters. Okay, so what you have is pretty simple. You have like your base, specular, transmission is for glass. You have subsurface scattering, which does not work right now. There is sheen, which is for like cloth kind of stuff. You have a secondary coat. Thin film, which is for like iridescent stuff, but thin film does not work. And there's emission and there's geometry, which is for like opacity and stuff. Okay, so you have like your base diffuse. Okay, you have your base color. Let me just get rid of the specular for a second. You also have diffuse roughness. Okay, so that is your diffuse roughness. And then you can also go metallic. Okay, like let me just bring up the specular. You can, define roughness. You can also do anisotropy. So if I increase this, see, so this is at 0 and this is at 1. And then you can also sort of like, spin the anisotropy. I think you're getting that gap there because I think that's where the UV map ends. So anisotropy is usually built around the UV map. I think so. But yeah, that's primarily I think why you're seeing that. Okay, if you're not doing metallic, then you also have like the index of refraction to control the, the reflection amount. It strangely goes below 0, which can start looking very weird. So don't do that. Like I think if it's 0, it becomes like metallic. Okay, but it also you get rid of the color altogether. Like you can change the specular color, like that'll work. That'll be fine. Okay, then if we get rid of this and this, like sorry, let's keep the specular. If we open up transmission, you get glass. Okay, absorption does not work. Okay, like scatter also does not work. So these things do not work. Like you can color the glass. Dispersion also doesn't work. Let me see if it works in Karma's CPU. Okay. So if I come here and I switch over to CPU, let's see if it works there. Let's hit Karma. Okay. You can see immediately how slow it gets. Okay. Yeah, I don't think it's doing anything. So I think even Karma CPU doesn't support this stuff. Okay. Does it support dispersion? I don't think so. Yeah, it doesn't support dispersion either. So even Karma CPU doesn't support this stuff. Okay, let's keep it to CPU. We'll just switch on subsurface scattering. So let's just bring up subsurface scattering to 1 and switch on Karma. And there you go, you have subsurface scatter. So let's do a subsurface scatter color. And you can take the radius and make it really low. There you go. Okay. And you have like subsurface scattering scale and anisotropy. So this supports it. Like let's say if I change this to something like a pink or whatever. Yeah. And let me just, yeah, there you go. See, so you have like full subsurface scattering. It is slow because it's CPU based. But if I switch over to XPU, you get nothing. Okay, so if I change this to XPU and I switch on Karma, you will get nothing. Okay, it becomes like a flat color. Okay, like it just picking up this color and nothing else. Okay, so Subsurface scattering is not supported. Let me just blur this a bit so we can bring up the coat. So you can get like a secondary coat. Okay, like we lower this. I'll increase the, see, so there you go. So you have like 2 levels of reflections on top. Okay, so that is coat. Sheen adds like a fall off around the edge. Like let's make it bluish. So you'll be able to see the sheen. There you go. But the problem is that it tends to make the diffuse darker. Like if I go to sheen 1, you'll just end up getting like this, which I don't like. Okay, like I think I used to think it's like an additive thing. So it just adds on top, but apparently not. So yeah, so keep it around like 0.5 or something, that's fine. Roughness is how much it will spread. So if roughness is 1, it'll just, spread all over. Okay, thin film also doesn't do anything. Like let me just try to bring it to metal. I'll lower and make this white. So yeah, so thin film doesn't do anything. Does it do anything in CPU mode? Again, this is very much in development, so you don't get a lot. Nope, it doesn't do anything in the CPU mode either. You'll notice when we go to Karma XPU, it's suddenly showing me like 3 different things. So it's showing me optics, like it's showing me 2 for optics and 1 for Embry. So Embry is like the CPU based sort of ray tracing system which was built by Intel, and optics are the ray tracing libraries built by NVIDIA. Okay, because I have like 2 NVIDIA cards. If you want to see full details, you can actually come in here, come to guides and turn on render stats and see, there you go. Like if I minimize this, see, so it should show you, see, there's a 3080 Ti, 2080 Ti, and then it has a Embry CPU. Okay, so it shows you like, all the details if you want to see that. So yeah, so the basic material isn't bad, like it gives you good results and everything, but yeah, there is a staggering lack of feature support. Actually on both levels, like I used to think like Karma CPU has more support, but yeah, it has support for some things, but even there it's a problem. Okay, let's get rid of this. And then you also have like emission, so you can just make it white. It'll give out light. And then you have like opacity, so you can, just do that. You can also do like, if you want to do transmission, okay, let me get rid of this. And you can make it thin walled. Okay. Wait a second. Oh, okay, it does work when you do thin walled. That's interesting. If you don't do thin walled, okay. Whoa, it suddenly started to work. That is weird. So thin film works with transmission? No, okay, it works with everything now. This is... Okay, if you do metallic, it stops working. Interesting. Okay, anyway, so thin film works. That's good to know. I mean, that's pretty cool. Okay, so, you learn something new every day. So thin film works. I just wasn't sure like how it works. So yeah, so I guess if you want to do like bubbles and stuff, that should be pretty easy. Like if I get this to 1, see, there you go. That looks nice. So yeah, so if you make it thin walled, you just want to do like bubbles, or things like that, you can probably do that. If you want to increase the ray depth and stuff, you can come into Karma and then you come to limits. Okay, so you come to limits and you have your diffuse limit. Reflection refraction is generally kept to 4. Let's get refraction up to 8. See if there is a change. Not really. Okay. Also, if you want, like when you do, we don't have a ground, but if you're doing shadow casting with a transparent object, make sure that you come to geometry and shading and turn on caustics. Otherwise, it won't work. Okay, like the shadows will be black. Okay, so that is as far as, like the basic material is concerned. Yeah, I genuinely thought that thin film isn't working. Anyways, let's go back to standard. Let's get rid of the thin film. Okay. Okay, so now we are going to build a basic material. Okay, so the idea is, as I said, like I built something in Substance Painter, and then we'll just recreate that in MaterialX. Okay, so I'll just show you the basic material first. All right, so this is the material that I had built. Okay, this is pretty simple. I just took like two smart materials and I'm mixing them using a mask. Okay, like if I turn this off, can I turn off the mask here? Toggle mask. Yeah, so I have like this, which is like a plastic shader. Okay, which is pretty rough. Like if I open it up, let me just see if I can. If I take the base and like, so I made it fairly rough. And below that is a bronze shader, okay, which is also like I just picked it up from the smart materials, and then I'm just mixing them using a mask. Okay, like this is, if I look at the metal edge and like there's the mask. So yeah, so nothing too fancy. Okay, so I exported all of this as like a 4K map, and we'll just recreate this in MaterialX. Okay, so I'll just close this. Okay, so the first thing to remember is if you're taking a texture, okay, like you get two options. If you come into MaterialX and texture 2D, you'll get something called MaterialX image, which you can use and it works perfectly fine. But if you type in USD, you will also get something called as a USD UV texture. Okay, now my recommendation is take the USD UV texture, because as you can look at these, this has way more output options, right? So this has just the color out, but this also has like RGB, alpha, and then RGB and RGBA. So it has like all of those options. Also, if you type in USD, you will get the option to do a transform 2D, okay, which is you can do like your rotation, scaling, and tiling, and all of that stuff. With MaterialX, there is no node directly available for modifying textures. Okay, like at least nothing that I could find. Okay, like nothing that could directly sort of allow you to modify textures. Okay, so anyways, like this works the same as the MaterialX image. So don't use that, use the USD textures. You also get like a texture coordinates thing. If you come into, hold on, let me just find it. So if you come into MaterialX and yeah, you get MaterialX texture coordinates. Now you don't need to connect this, okay, because if there is only one texture coordinate that I had, if it just has the basic UV map, you don't need to connect this. But if maybe you have multiple UV maps, you could use this. Okay, so anyways, right now we'll get rid of it. So we'll just take this, connect. Honestly, we don't even need this right now because we're not going to do any tiling and stuff. Okay, we'll do that in the next lesson. Okay, so I have this and I'm just going to pick up my basic texture, which you can do from the file. Okay, so if I click here, like if I look at it, it should show me what I need. Yeah, there you go. So that's the base color and then height and everything. Okay, so pick up base color. For some reason, it takes a while to load up. And we'll just take the RGB and connect it to base color. And if we switch on, are we on XPU? Yeah, we're on XPU. So if we switch on XPU, I should be able to see my base color. There you go. Okay, so pretty straightforward. Okay, so if you can come in here and then I can just take, we'll just do Control C, Control V. Let's pick up the metallic. Yeah, so I can come in here and I have metallic. Let's just call it metal. And I'll just make a couple of duplicates. So we'll do Control C, Control V. Let's call this roughness. And we'll pick up the roughness. Wow, this is slow. I don't know why it's slow. But yeah, you'll find like weird slowdowns for some reason. We pick up roughness. And then lastly, we need the normal map. Like it doesn't directly support height maps. There is a height to normal map conversion node, but it didn't work for me. Like it gave very weird results. I'll show you what it does. Like I'll just pick this up. We'll pick up the height map as well. Yeah, so that is the height map. And then lastly, let's call this height. And lastly, I need the normal map. So pick up the normal OpenGL. There'll be something called normal OpenGL. Yeah, this one. Okay, so the rest is simple. Like we can just pick up any one of these because it's a black and white map. This goes into metalness. See, and then this comes into the specular roughness. And it's taking a little bit of time to calculate. Yeah, it is working. Okay. I was sort of wondering whether it's actually doing anything or not. And then for the normal map, what you need to do is just type in normal and you'll get something called MaterialX normal map. Okay, so just take that and you plug in the RGB into the in, and this comes out to the normal, which will be there, at the end. And there you go. That's it. That's your full shader. Now you do have something called as height to normal. So if I just type in height, you'll get something called material height to normal, but it doesn't seem to do anything particularly. Like if I take this, now this has been converted, and if I plug this into the in, yeah, it does that. Like everything becomes faceted. So I'm pretty sure this is a bug, or if I'm doing something wrong, you can let me know in the comment section. Okay, like maybe there's another way to do this. Okay. Or something that I am not turning on or whatever. Okay, even that doesn't seem to work. Anyways, so yeah, mostly you just want to use like the normal map. Or if you have a height map, then convert it, Like you do get height to normal utilities, you can use that. But yeah, the basic setup is pretty simple. Like you don't need to do too much. Okay, so I'm going to stop here. Okay, what we'll do with the next lesson is I'm going to build a similar material, but we'll build it from scratch using MaterialX. So rather than building like a full material in Substance Painter and just connecting 4 maps, what I'll do is I'll just paint a couple of masks in Substance Painter and then use those to build a full material in MaterialX. So we'll have like more control. And we'll also take a look at some of the other sort of compositing nodes and color correction nodes that MaterialX provides you. Okay, so we'll build like a more sort of customizable material in MaterialX with the next lesson. Okay, that's pretty much it.